Okay, it looks like we are live. So welcome back. I'm going to be continuing to work on my virtual machine. So I have worked on it just a little bit since the last stream. So if I build that, actually let's build all the tests as well. Now we have the test. So I did modify the Fibonacci test a little bit. So now we can run. Yeah. So it is compiled already. So we can run test fib.tim, and now it stops without piping it into head. So if we open it up, you can actually see how that works. So basically, this is the number of iterations. So it's set to 20 right now. And yeah, so basically we just increment it, and then we subtract from it, and at the start of each loop, we compare it with 0, and if it's equal to 0, then we jump to the end and stop. So yeah, it's not too super complicated, but now we can change it and print as many iterations as we like. So if you want to do 30, then we could recompile it. There we go, and there we go. It does 30 iterations instead. So yeah, so that's pretty cool now. Yes. So I also modified a few things, but today I want to add floats, at least floats, and probably like maybe unsigned integers, signed integers, and then floats. Right now we'll work on floats. So let's actually modify the lexer first. So that should be fairly easy. So basically, we can check is digit. So let's actually go to that function. Is digit, or no, generate int. Yeah, that's what we will call it. So maybe we should change this to generate number because we are going to be, yeah, let's do that. No, generate no. And then down here, we're gonna have to change the name to no. All right, and I think that is, yeah, that's the only place I will use it. So I think we do declare it in the header file as well. So I just want to fix that, make sure. Yeah. So we'll change this to no. All right. So what we are gonna do is, so we're gonna check at the end here if current index equals a dot. Yeah. So if it is a dot, then it's a float. So we know it's a float at that point, because that's the only time that you would have a dot at the end of a number like that. Then we're gonna have to continue through, but we know it's a float. So I think we can set the token type equals type float. So we'll have to add the type float. Yeah. So I think the better way to go about doing this actually would be first check if it is not equal. And then we can put everything in there. Otherwise, like we don't actually have to do else because we return there. Otherwise, we'll do this. So basically, oh yeah, keyword name, keyword length equals current index. So we know that that is going to be a period, a dot, whatever. And then we can do current index plus plus, and then we can do wall is digit current index. Then yeah, and also I think this will work if you just put a dot at the end, and it will just automatically assume. I think that's still but we'll test that obviously. Then we'll just do the same thing here. So basically doing a secondary loop. So yeah, basically just this exact same thing here. We do have to iterate keyword length as well. And then at the end here, we can do keyword name, keyword, whoops, that's not right. Keyword length equals the end. And then token type equals type float, which we do not have yet. And then we'll create the token type, keyword name, line, and character, and return the token. So, so that should all work now. Yes, indeed. So let's actually try that out. So let's see if it compiles. It does not because we don't have type float. So that should be pretty easy to add. Just right under the int. I suppose it's really int literal. I'm not gonna worry about that right now though. Alright, type float not handling switch. So that is actually in the chasm.c. So let me see, do we have a switch in here as well? Switch. We do indeed. So we need to add it here as well. It just doesn't, we have the default, so it doesn't print. There's probably a way to enable that, so I need to figure that out. But yeah, we'll just put type float, and we'll return type float. Okay, and then we have to add it in here as well. Otherwise we get the warning. So float, and it should not be float. Alright, yeah. Because other than that, it should be mostly handled the same as an int. Oh shoot, we need to add it here as well. No we don't. That's the keywords. Okay, so it should compile now. Alright, so if we run it, then it does actually work. So let's print each token here. And we can see what we have. So we don't, let's make a test file actually. So, and yeah, I will just edit that file. So push 5.0, something like that. Now we'll run that. And do we have, and I ran on the wrong file, so let's not test. Okay, expected int. Alright, but we did get a float, so that did work. Yeah, so that works. So if we go into the parser now, parser.c, let me actually look here. So I'm assuming, it doesn't say where that's at actually. So in the switch, yeah, so we are going to have to change some of this around. So here, we can do the same thing as this. And then we also need to check int here as well. Actually, I'll do it before this because that makes a bit more sense. So lexer token stack index dot type is not equal type float, and that. Yeah, so we can just do this exact same thing for all of these. I think I can, if I do that, I will just yank it and paste it in there, and that should work, I think. So yank, paste. All right, and we can do this for all of the ones that have an operand, basically. Oops. There we go. So I think this is the last one. So now, all right, duplicate case file. Oh yeah, I did not actually change this to type float. All right, and let's see. Let's not type. So now, let's see if it is all handled actually. So let's not print the tokens. All right. So now, if we go down here, let's print the list that it generates, and it should generate it. Yeah. Okay. So we have push, and then we have 5. So I don't know what actually is going to happen if we run this right now. It doesn't do. Oh yeah. Well, so let's add a print. Whoops. Mess that up. All right. Let's chasm, and then run that, and 5. So it just treats it as an integer right now. And I think we can do, yeah, because we're doing ASCII to int, so it's just gonna be treated as an int. So we need to check whether it is an int or a, yeah. So that'll actually, let's see, will that be in here? Yeah, okay. So if head value dot type equals type int, then we're gonna do this. Else The only other thing it would be is a float right now, so we can just do else. I can do it properly. So I think we can do ASCII to float. That should work. So, hey there, how are you doing? Eager. That's how you say that. Oh yeah, I need to do equal. That's my bad. All right. No, that's not right. I thought that was in the if statement. So instruction value equals that. There it is. That's what I meant to do. That was a stupid mistake, but okay. That's not TASM. All right. So it's still treated as an int, but it should be working properly. So we can just add this to each one of the instructions with an operand. And I don't want to double break there actually, so Alright, this one has an operand as well. Why is there a double break on all of these? I mean, it's not a big deal because it doesn't matter, but no point to it. Alright, and just a few more. I think this is the last one now. So yeah, there should be, yeah. Alright, so let's see if that works. So I didn't mess anything up, it looks like. So let's see, what do we need to do? So let's try in the, we need to actually modify the in.c file. Okay. Yeah, and then, okay. Just swap problems. Alright, so push should work fine. Well, actually, we're gonna have to modify in the dot header file. That is the same problem. Alright, because, so the operations will only work on ints right now, or it'll be kind of confusing. But we need to change actually in here. This needs to be a different type. So if we do something like union, and then this can be I think it's called a word. I think that's what it's called because it'll be, we use 64-bit now instead of the 32-bit stuff. So it's 8 bytes. So I'm pretty sure that it's called a word if I am remembering correctly. So let's see, just int 64t as int. I think we can do something like that, and then we can use double to be as float. I think that'll work, and then we can change this to word, and that's gonna mess up. It's gonna break a few things, I believe. So yeah. So when we print, we should probably just, well, so when we print for each different type, so I think there's no harm in just doing it as float right now. So we do need to modify that actually. So let me see, where was that at? It's in print. F, B. Alright, so I think we can do this and then do as float. I think that gives us the best information because it'll just print the, oh yeah, we'll change this to be a float. And there we go. So expected int, but argument is a type word. Yeah, so push that. So we can set push to accept word. Push. Alright, right here. Yeah, so instead of int, we will accept a word. And let's see, what else? So alright, argument of type int. Can we not do that? Okay, let's see, where are we doing that? H machine 0. So can we do it like Alright, well, let's see what else we can do. Alright, yeah, so that's just all That's most of the problems that we have. Um, I don't think that'll work. So let's see. Push. Yeah, so that doesn't work. We get a lot of errors when we do this. Int was expected. Right. So that is in the pop actually. So we can return it as, well, no. Let's just make this a word. All right. So yeah. So we can actually, oops, didn't mean to do that. Set B. Yeah, right here we can do this, and then so we'll do it as float. As float. All right. Yeah, and we need to change this to float. All right. Valid operands that have word and int. All right. Yeah. So we can compare that as int. And I think that is reasonable. We're gonna have to make changes to be more dynamic than this, but I think it should be fine right now. So let's see, where else do we have? We have this. Let's see. So expected word, but argument is of type int. Yeah. So how do we fix this problem? Yeah. So let's make A and B a word as well. All right. Let's just go through some of this. Arguments of type int. Yeah. So yeah, these are the, we need to interpret these, so we'll do as int. Then we'll have a whole set of separate operations for the let's see, for floats. All right, and there's one more after this. That's int. Okay, and yeah, this one. All right, so let's see now. So invalid operands. A does not equal B. So I'm not sure if this will work though, because with the ints there could be certain things that cause this to not. Um. As float. Okay, and then last one. As float. Okay, so let's see. So that should have, alright, there's still a lot of them. Alright. Okay, so push, yeah, that's not gonna work. Cause it's an int 64T. So, yeah, so that doesn't work. Word. Okay. this is actually, let me clear, run it again. Then we can, yeah, we still scroll past, but, expected word, but it's a type int. Okay, so we need to modify some stuff. Okay. So how do you, let's see, how do you pass union as argument as argument, rather. Yeah, this is what I want though. Call the union. Okay, so but I want to be able to pass integers as well. Okay, I am back now. I really apologize for that. My internet just died. So I'm back. So I got it working, kind of. It's a little scuffed, but it does work. So if we can run the Fibonacci, and that'll work exactly the same because I haven't done anything with that. So yeah, that still works. And then I have this test file here. I'm gonna make it 5.0. Alright, and if we run that, test dot TASM. So it will print out, tries to print it as int. And obviously that's not what we want it to print. So we can modify it to be as float. Yeah, and then I have to change this actually to that. There we go. Alright. So it doesn't work. So it's because there is other places. There we go. Okay. Yeah, so actually let's run test.tasm, and I have to recompile it actually. Test.tasm, and also it is the team file. It's not team. There we go. 5.0. So that that'll work. So I think we're gonna need two different operations. One print I, and then print F. So how okay. I mean, we could do both. Trying to think. Is there a good way to go back to it? So let me give it a actually. So if I do do this, I'll print it as float, and then as int. Alright. Yeah, make that print again. Alright, and if we try to run it, stack under, oh yeah, because we were trying to pop it twice. So let's actually do a equals pop machine dot there, and then we'll set this to be a dot x float, and a dot x int, and I forgot a semicolon. Classy. Right, whoops. So that'll work. It does kind of mess with the Fibonacci a little, because yeah, obviously prints them both. So I mean, it's not ideal, but really the print right now is just for debug and it's not really going to be used. So I think it's good. Yeah, if we actually put as float, as int. Alright, and then yeah. So it looks a little bit better. Perhaps they could be on the same line. Something like yeah, do that, and then add int is LD. A dot as int. Oops. There we go. That's not right. Because I forgot the new line. Alright, run that, and there we go. Yeah, so that's a little bit nicer. and it's all lined up properly. So we do technically have support for floats now. Not completely ideal, and not everything works properly because of the operations. Yeah. So I don't think there's a way of getting around like having separate operations, one for in and one for float. Yeah. So you can see we're just interpreting it as this and then casting it to word because that is what we use in the push. Yeah. But yeah, we can push either one. So that is good. We can push it as a word and then interpret it that way. And dupe, it only accepts an in as an index actually. So perhaps we could actually modify that in here. Like with this, it should only ever be int. Because you can't jump to index 5.5, but we do interpret it. Let's see. So what if we do like in swap 0.0? What will that do? All right, and okay. Actually, let's push 7.0, and then we'll recompile that. Okay. So it looks like that does work. It is kind of weird seeing the as in and it's just a giant number like that. Yeah. But so that'll work because we just interpret it as an integer and yeah. So I think that is probably fine. Index that. All right. So maybe it's not fine because yeah, that's not gonna work. All right. Yeah. So we'll have to make that only accept int. And I think that's fine. So we can actually modify the parser. That's here. So yeah, so actually on the jump, yeah, we don't want it to be float either. So we only want that really on push, right now at least. So we can get rid of that entirely. Yeah, any of the jumps and the swaps and the dupe. Okay, so let's do, and then push, we do want that. So now this should actually break it. Okay. So why is it doing that? Okay, let's see actually. So in the file, yeah, it should just be okay. Alright, yeah, so that is actually a to-do that we have. But yeah, so that does work. Seems to work. But if we replace this with, well, actually, that can still be something now, but then this can be 1. Then it should work. Yeah, and then if we run it, it's not 10. And there we go. Yeah, so then it works as expected. So that is good. So we can actually modify this. So, yeah, we shouldn't have to worry about that because we do check it. So, we don't need that for any of these operations. We do need it for push. That's the only one that we do need it for at the moment. Because these are going to be different, the mods and such. Alright, yeah, we do that for all of these. Alright, and I think that is good. So let's make sure it all works. That's not chasm. It's not pin. Alright, and chasm s slash bib dot chasm s bib dot 10. And it seems to work. Okay, and we should, since we switched to 64-bit, we should be able to print a couple more Fibonacci numbers. So if I actually just fib dot, let's change this to 60. Okay, and let me make sure that actually works. It did not. Okay, so it didn't let me actually modify it. So I have to open a new thing and then text and fib.tasm. And yeah, so yeah, anyway, change that to 60. Alright, and then like, okay, now test slash fib.tasm. Yeah, and now it is bigger numbers and it doesn't overflow. So this should actually be the 60th Fibonacci number. So we can test that. 60th fib number. And I don't know why I did it with double B, because that's actually not, it's not what it is. Yeah. Alright, let's go to 60. So I'm going to paste it in here. That is not right. Let's see. Alright. Should be this one. So number 60. Alright, maybe, so we want to round that. Let me search for that. 3654 35 2. Alright, so 57. So alright, that's a little weird, but it is a valid number. Oh, because I was looking at the wrong one actually. Yeah, alright, so it's the 59. So it's just, that's fine. That is actually correct. Yeah, so that is working now. And we can print much larger numbers. And we have support for floats. So, yeah, let me remove test.tatsum as well as test.tin. And then let's go to test and let me test dot, or yeah, so float.tasm. Let me actually remove float.tasm to .tasm. So I can open it up here. Float.tasm. Okay, so let's just create an example. So we can push 5.0, push 2.0, and we cannot add. That won't work actually. So we can test that actually. Print. And then if we go to compile it, so run float.tasm, float.tin, and yeah, obviously that doesn't work. So we need to fix that. So we need to add f. So I think I'll just leave standard integer as add, and then add f. Yeah, so let's do add f first, and then we can worry about adding all the other operations. So I think we can start on the level of the parser actually. So where's add? So I'll just add it immediately after these. So add this. Right, and that should be good. Type add f. Add f. Alright, and yeah. So we can do that up here as well. Type add f. Okay, and I think that's the only place I've changed there. So we need to actually open tasmlexer.h and add f. So if we click add, put it right there, add f, then we do have to handle that in our switch statement. So here we can just take this and do add f. Okay, yeah, I was just thinking, probably a way I could condense this, since only with a few things I am actually doing other stuff. I don't need to worry about that right now, though. So, and then in tasm.c, if we encounter add f, right here, add f, then add f, add f. And then, now we have to modify the tin.h file to support add f. Add f. So, and then we have to modify the switch statement in here. Yeah. to support add F. Okay, so yeah, then we pop it, and then we can do as float and just add as float. Okay, then all right, so we have some problems. Type add F. So I thought I added that. Oh, add F. There we go. All right, build it again. All right, and it seemed to work. First try maybe. So yeah, let me actually in this. Let's see this one. That's not the right one. We deleted that file. Float that tag. There we go. Yeah, add it. We already are using that. So we run that on the float.tasm. Alright, and let's see, we have add app. So it should be able to float.10 and 7. So is that actually correct? That is correct. So we successfully added add app. So if we do integers, then what's gonna happen? What is gonna happen? Float.10 and as alright, so it does actually add them properly. Huh. Alright. Oh, that's interesting. But it doesn't work the other way around. So that's the thing. What happens if we try to do something like that? Right. Yeah. So then it just messes everything up. So you can't combine stuff, but we do have add app. And so it should be pretty simple to do the exact same thing for the rest of them. So yeah. So we have sub, multiply, divide, and mod. Mod f, and then this is div f, multiply f, and then sub. Alright, and then we have to add same thing down here. So after add f, you just take this and do paste, 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 paste. Alright, so add f, sub f, let's see, mulf f, mulf, that's pretty funny. Alright, div f, and then what is yeah, mod f, div f, sub f. Okay, so yeah, now we have all of those. So this is not right. Okay. Yeah, this needs to be mod actually. And then this is it. I did it in the wrong order. And then there we go. Alright, so now that should be working. Okay, and I think that's the only thing that we have to change in here. So in the parser, actually we do have to add those to the header file. So yeah. So sub, and then this is multiply, divide, and then mod. So that should all be working. And then in the parser, we have to handle them, of course, same as this. Right, so mod f, and yeah, so then this is div, multiply, and sub. Okay, so that should be working now. I think that's the only place we have to handle that. Okay, so the last place, for this at least, we need to add the operation to the actual virtual machine. But for the assembler, this is the last place. So add f. And obviously, there's probably some ways I can change this up to make it more efficient. Rather than having all the different switch statements, we can just make like one or two. So that's something I'll do off stream. Multiply and sub. Okay. Let's see, multiply f, div, and mod. Okay, so that should be all that we need for that. So it's not going to compile because we don't have it working in the virtual machine. Yes, undeclared instruction. So fairly simple. Sub, multiply, divide, and mod. So now, alright, not handled and switch. Yes. And then everything else seemed to have worked, so that's pretty cool. First try. Alright, so if we like that, 3 and 4. So then now we have mod. So it is very similar. Probably make a macro for this that just expands into this. I will consider that. So this is going to be divide, div, sub, nope, multiply. This one is sub. Alright, so alright, invalid operands. So you can't divide foot. Is that a thing? Oh, you can't mod foot. Alright, that is probably fine. Is that not a thing? That doesn't work in C? Or am I doing something wrong? So what if we do assert fault? And let's just see. So, yeah, alright, that doesn't actually fix this. Oh yeah, we don't have false, so I'll just assert 0. I don't feel like including std bool right now. And then everything else works. So I'll have to, let me see. Mod on floats. Let me see. Oh, okay, you need math.h. Okay, yeah, fmod. Okay, yeah, so we can do that actually. That's not too hard. We'll just include math.h. Include math.h. And I'll probably include std bool as well, because I'll use that for stuff. So, yeah, we can do this. We can just do mod f, that, and that. And that should work. Let's not insert anymore. Alright. Expected double. Alright, we need to pass a pointer to it. No. Alright, let's see. Oh, because I'm not actually linking with it. Yeah, I'll do this as like a 2D. So I don't feel like doing that right now. So assert false and to do not implemented yet. Yeah. There you go. Alright, yeah, I'll do that after. So I think I can that work great if I leave that. No, alright, so that'll work. Yeah, so let's try that. Float.test. Alright, alright, so let us try doing another operation. So that is in here. Alright, let's see, what operation? We'll try sub. So that should be 5 minus 2. That's what I have it set up at least. I didn't need to rebuild, so I don't know why I did that, but alright, let's see, and we'll run float.10. Okay, 3, so that is good. Multiply, again, and 10, okay, and then divide. So let me actually make this 6, because then it's, well, actually, no, then we can see the greatness of, uh-oh, I did it wrong. It shouldn't just loop forever, but I'm not gonna worry about that right now. Float.10. Alright, 10. So I need to do pivot. 2.5. Okay, so floating point numbers seem to be working. That is pretty cool. So Can't do mod, it will just assert, and yeah, won't work. As yeah, so that won't work, but everything else works. So let's see what yeah, what was that? So if you just have an invalid token here, why does it loop forever? Yeah, that's not good. So does this mean that labels are not working anymore? Let me actually test the labels. Because I do have the test slash label dot test. Okay, so that works. Test slash label dot 10. And yeah, so it's still working. So I'm not sure why it would loop for it. Is it just specifically being after a float? Could that be the problem? I could see that being the problem. No. So it does that. Perhaps we could debug what is going on. Not using a debugger, but instead using print statements. Yeah, so I'm assuming it's happening in the Lexer. We can find out. If we get past the Lexer, then this will run. Okay, so label. Yeah. So we do actually, it's in the parser. So, so we're having a problem in here. So it just goes forever. So let's actually print how far we go. We can print each individual token and we'll see where it stops at. Okay, it just goes forever. Oh shoot. Are we going, oh, we seem to be going back and forth. So, ooh, okay, so it's actually a problem with my label. Yeah, if I get rid of this actually, then it's gonna, yeah, then it works. So, yeah, it was kind of my scuffed fix, for a problem that we were having. Causes problems. It should have given us an error though. No, because we, oh, okay. So the problem, yeah, I need to fix this better actually. So the problem is that you're not supposed to be using labels unless they're followed by a colon or preceded by like some sort of jump or something like that. So that is actually the problem. So that's something I will not worry about right now. Yeah, but we'll do, yeah, so this should still be working. Yeah. Okay, so we have all new operations and support for floating point numbers. So that's pretty cool. So I'm thinking, would we be able to have support for individual characters as well? Strings are going to be more complicated because they take up a lot more space. But I feel like string or characters, we could push individual characters onto the stack, and then just print them using, well, so yeah, if we have print, then we can print like we have as float, as in, and then we could have as character, and just print each. It's not, then we could print hello world technically. I think that would work. So let me actually try that. So let's just do character as character. This might not be where you're supposed to do it, whatever, but I don't care. Yeah, so as character, so still compile. So then in the print, obviously we don't have support for it yet, but we can get it set up as float. Let me actually add a comma to separate it, and then as character, and then we'll do a dot as character. So obviously it's not gonna, it's gonna look kind of weird right now, because it actually won't print anything. Okay. So yeah, so I think if we just add it in the Lexer, if we encounter, let's see, so if we do something like else if current index equals, let's see, I need to like escape, I'm not sure if that's right. I'm assuming that'll work. So actually we can test that. Test that. Right, and let me actually not print all the stuff in the parser right now, because we do not need to do that. We have this, and I think we also have it up here. Yeah. So I'll just comment all that out, because I'm going to use it later. Yeah, so if we run that on float, we actually need to modify it, though. So, yeah, let's just do push. Let me just give it all that. Push. There. And let's see what happened. Whoops, I didn't need to do that. There we go. Undeclared label C. So, it did actually work. We did encounter these. So what we need to do is generate character. Generate character. Yeah. So it'll be very similar to the other functions that we have. During index, line, and character. Alright. And yeah, we will push token, and current index. So yeah, we're gonna do all the same stuff as we do here. So let us go and create this generate character. I think we can do something more like this. So yank this, do generate character. Let's call it char, or did I? Yeah, let's do car. Generate char. Yeah. Okay, so we need to accept that, and yeah. So yeah, keyword name. Which is do character name. Character name, and then so it's actually gonna be a little different because it's not a string, so we only can have one character. So yeah. So basically, what we need to do is current index class equals 1, and then if not is alpha current current index, then we will just throw an error, error expected alpha character. Yeah, something like that. And I'll add better error handling in the future because we have all the stuff where we are tracking the lines and the characters. I just don't actually display it. Otherwise, so we'll exit there, and then yeah, so we can set just the character name equal to, well, so it's gonna be a string. So character name 0 equals equals current index, and then we'll do same thing basically. Current index plus equals 1. And we can do the same thing here, but we just want to check if it is if current let's see, I need to do this. Current index does not equal this. There we go. Then expected that expected close quote. Single quote. Okay. Yeah, and then we can do this, but for the last, just the 1 equals the that one, because it is a string. We had stored a string. Yes. Then we can do this. So then token type equals type character. Yeah, so we don't need to check that actually. Yeah. So we need to pass character name. And then return token. So that should all work. Let's make sure there is no errors. Alright, so the only error is that it's undeclared. So we can modify that and make it not undeclared in here. So after type float, we'll have type char. Right, and if we build it now, alright, type char is not handled. So we can handle that pretty easily. So we don't actually need to handle it in here, but in here, okay, type char, and then it is also not handled in the other switch. So we can go ahead and do that in here. And it's just the same thing. So see, it's actually down here. So yeah, we'll do the same thing as that. But again, I need to fix this. I'm not gonna worry about it now though. So then that should be all the places that, all right, that is just in the test.c file actually. So yeah, pretty easy to add it here. It is, yeah. So it should be the same actually. So type char should not be char. And then up here we need to add it. Okay, so just in the push, because yeah, we're not going to perform any other operations on it. So else if head value dot type equals type float, and then else if head value dot type equals type char, and we'll do that. Else head at either maybe this can be an assert actually, because we shouldn't make it here. Should not be here. We should not be here. There we go. And we'll add that. And then yeah, don't need to exit because it's an assert. Yeah, so we can just do the same thing. Value dot as char equals so yeah, we can just do head value dot text 0. And that should work. So let's see if there is errors. Okay, so now see if it works actually. Chasm float dot chasm expected alpha character. So right, it didn't work. So in here, that is an alpha. All right, let's print what we are seeing. So that is gonna be, that's gonna be down here. Let's print, well, we're not gonna make it here actually. So let's see, this actually only has to be times 2 because we only have 2. But now let me printf current index is current index, and we'll see what it is. All right, current index is C. So so why are we printing that twice actually? Why are we calling this twice? Oh, you know what? I know what the problem is. We don't want to. Is it because of this? Probably is because of that. So if we do that. Okay, so that worked, it seems. But now we have expected type in. So that, let's see. What file is that in? It's back here, I think. Yeah, so I didn't actually add the handling to the, did I? But I did. Type in, yeah, okay, so I didn't add it to the push. So that is quite important to do. Yeah, Lexer, token stack index type is not equal type bar. Alright, so let's see now. Okay, so that seems to work. So let's actually print all the tokens and make sure that they are correct. So we can get rid of this print statement, and we can just print all of the tokens here. And we should see type char. Yep, okay. So let's not print that now. And let's see what happens if we run float.t. Nothing happens. Okay, so we don't actually print it. Let's print. Chasm float.chasm. And as char C. So there we go. We can actually, we can do this. And then actually we need to do that in the reverse order. 4 or 5. Yeah. Because otherwise it's gonna print it reverse, I think. Yeah, it's reversed. So yeah. We could write something to actually reverse it. I'll just manually reverse it now. So it's gonna say hello. Are you ready? Bam, hello. That's pretty cool. So it's not strings, obviously. It's just individual characters, but it is still quite cool. And we should. So we don't actually check that. So this is gonna be an error. Yeah. So we can. We need to support that. So actually, we can support pretty much anything. So maybe I don't need that check. We just need to make sure it doesn't go out of bounds. Alright, well, yeah, so we'll just get rid of that actually, because, yeah, alright, so let's try that now. In here, there we go. So now let's see what happens if we run that, and it puts a space. Alright, so I need one more print actually. This should go at the top. There we go, so if we run that, and there we go. So we can print spaces now, and we should be able to print basically any character. Yeah. So that's pretty cool. So let me actually. One more. Hello world. Alright, I didn't need to build it. Alright, and I forgot to add all the prints. So, yeah, we could obviously add a loop to do this, but. Alright, I think that is right. And there we go. Hello world. Yes, I think this is funny. So I'm gonna save it as a move chasm into hello world. Just for funny. Move hello world.chasm to best. Not CV move. Okay, so now we have that in there. And alright. Move field.10. And now we can build all the tests. And it should have built the hello world.tim. Okay. So test slash hello world.tim. And there we go. Yeah, so this is hello world, kind of. Not exactly, but yeah. So that's pretty cool actually. So now there's a lot more we can do with this. Yeah, so we have supports for float. Is there any other types that aren't strings that would be useful to implement right now? That wouldn't be too difficult. I don't think so, really. I'm just trying to think. What is something else that I could implement? It won't take too long. But then I could do rather quickly. So also I was thinking, the original plan was to have registers as well as a stack. Right, so you could like move into RX or whatever, you know, like how x86 assembly works. But now I'm thinking, since we have arbitrary access to the stack, because we can just do like index swap, index dupe, all that stuff, I'm not sure that's necessary. Like, I haven't thought of any particularly compelling reasons to implement registers, or reasons that we would need that. So I'm going to continue thinking about it, because I'm sure there is reasons. But if anybody has any, then I would like to know. Yeah. Yes, indeed. Because yeah, I didn't really, like, it seems like we can do pretty much all that we need with just the stack. But maybe not, because Java, the JVM, has a stack, but it also has registers. So, yeah. So, okay. So let's take a look. Yeah. I'm not going to add pointers to this yet. Yeah, I think that's good. So, actually, we need to modify one other thing in here. Because we have the print stack. And I did modify it to support. Yeah, let me do it all in one line, like how I do with the other one. So as float is %f, and then as character is that. And then this is useful for debugging and such. I dot as float chain stack I dot as character. Okay, so now if we print the stack, yeah, print the stack. So let's just do that. No, I'm thinking you could just use print stack here instead of this, since it's basically the exact same thing. Well, it's not exactly the same thing, I suppose, because yeah, but we can do that for testing purposes. So let's actually just run. Okay, let me remove build.test. All right. Test slash hello world dot test. So this is dot 10. Okay. Yeah. So it prints. Yeah. So it's not the same, but you can see how this would be useful for debug purposes. So I will keep that, but I'm not going to use it here. But that is working. So. So what's something that I could try to implement in the assembly? That uses floats or characters. Because we have the Fibonacci. Let me actually. Yeah, there we go. Oh dang. Okay, I actually got rid of the Hello World example. I forgot that that would happen. Yeah, I forgot to commit. So let me get out of that. Let me fix that. So I will just rewrite it really quick. So B. Alright, I think that's right. And this is like space. World. There we go. And then yeah, so print. Let's see. Actually, I can do. So yeah, that should be right. So let me just make sure it works. Okay. So it's still doing that. Actually. Let me rebuild it. And there we go. Yeah. So world. Oh, I just typed. Okay. There we go. Hello world. All right. So that is working again. So let me actually move that back and then test, and then I will commit this. Implemented floats as well as characters on both the VM level as well as the assembler. Also added hello world example. Okay, so I will push that. So that should be up now. Yep. All right. So now I should be able to safely. Let me see. Let me make sure it's there still. Yep. All right. So if I run that and then do that, and then hit clean, then it should not have removed the. Yeah. All right. So that's all good now. So that is what we wanted. Yes, indeed. All right. So what can we do? So what's just like, let's see, like project, not Euler's. All right, it's fine. Is there? Let me look at some of the. Let's see, where is it? Archives. Let's see. So multiples of 3 or 5. All right. I could probably do something like that. So let's try that. Let me get out of that one. Let's touch 3 or 5. 3 or 5 dot as, and then I'll open that up. 3 or 5. Okay. So actually, before I do that, I'm going to add comments really quick because I think that should be fairly easy. So let's do something like else if current index equals for comments I'm going to use a semicolon equals that, then while current index does not equal that, we will do current index plus plus. And that should just ignore it. We might have to do incremental line number. Well, let me print all the tokens back again. So I think that's all that we need to do. 4 comments. Because those are actually extremely useful when you're working with the stack and you try to keep track of it all. So I'll just run chasm test slash hello world. So line 22. Is that right? Alright, I don't have any comments in there, so it's not going to matter. So let's see. Close out of that. Alright, let me just do test. Print. Alright, so chasm 305. Alright, so print is line 1. So we need to increment the line number because that is not line 1. And then also line plus plus. I think it's just called line. Yes, indeed. Okay, so now we build it again and run that. Yeah, so we just have the character for that, and it's the correct line number. So, yeah, we should be able to just put test wherever we want, and then here as well. And then push 5, and make this something that won't mess it up. And then print. Yeah. So, let's see, we have print. Line 4, that's correct. Yes, line 3. Okay, so, seems to be working. 3 or 5. Tim. And 5. Okay, so yeah, now we have comments. Because that's really useful for keeping track of the stack and such. So I can actually comment this out again. And rebuild it. Alright, so I want to be here. So now we can try to implement this. So basically, we will push, we'll do 10 to test it, get it working, and then we'll modify it. So this is n. This is the n, yeah. Okay, so all the numbers. So we're just going to increment it by 1 each time. So we'll start at 1. And then we'll also push 3. Let's see. So we need a count as well, or that sum. So we'll push 0. So let me keep track of the index. So this is 1, this is 2, and this is 3. So that's the index that we have. The index in the stack. So, and the first one is 0. So that is the sum. That's the first number. So that's the starting number. So, and then if we do mod, let's see. So mod, so we should just be able to mod that. And then that should do 1 mod 3. So that returns 1, right? But if it becomes 6, then it should be 0. Yeah, okay, so that's what we want. So jump if it's 0, or actually compare equal. Yeah, so I think we can do push 0, or thinking actually, if we make like set this to be main, and then we make a label here, which can be add 3. Well, I can't do that, so add 3. And then jump 0, add 3. Not tree. 3. And then, so if it's 0, no, we don't need to push 0 then. So yeah, if this is 0, that's the number that we're comparing it to, and that is that. If it is 0, then we will take the first element of the stack. So in dupe, do you want to dupe or swap? I probably want to swap. In swap 1, and then push 1, and then add, and then jump to to continue. And that should work. So I think that should, well, we actually have to change it back. We have to put it back to its original location. Okay, yeah, so let's see, so that is in 1, so that is going to be, so what did it actually put there? So when we mod, So that actually consumes it. So after the add, we want to do that. And that should put it back to its original place, I think. And then we'll jump to continue. Then we can do, we should have the correct number. So then we can push 5 in mod. And then jump 0, add 5. Add 5. And then we can do basically the same thing. No. Yeah. Actually, we could just do... Yeah, it doesn't matter though. These can be the same. Add count. Yeah. So yeah, that can just be add count. Add count. Okay. So and then at the end, so we need 2 continues then. Actually, Alright, so actually I will swap them, or I will, I'll do that. I'll make that demo. Alright, even though they're going to be doing the same thing, but it just makes it easier with the labels. So yeah, jump, cont to, or cont, conts. I'll change the label name, after. Add 5, and add 3. So yeah, so then continue. So then we should have, let's see, so this one should be on the top. We might need to push 1 again actually. So let me work through what happens here. So we have 10, and then we have 0, 1, and then 3. And we do mod, which actually consumes both of these and puts 0. And then if it's 0, then we jump there. Then we swap these, so then it becomes 0, and then still 0. And we push 1, we add them together, so it becomes 1. And then you swap them back here. So yeah, then we need to actually push the number again. Wait, so what is the purpose of that number again? The count? No. What is it? So that's just what you compare it to. Yeah, so we need that number back. So we can't consume it. So we have to duplicate it. So if we do and then we need to do it again afterward. Yeah. So then that should work. So let's run through it again. So we have 10 and then 0 and then 1 and 1 again and then 3. We mod it. So then it'll push that. Jump 0 there. So we push 1. No, we swap it. So swap 0 and 0, we push 1, and then we add them together, and it becomes 1. Then you swap it back, so then this becomes 0, becomes 1. Yeah, okay, so I think that'll work. And then so we need to basically, whatever's on the top of the stack, we can just add 1 to it. And add 1. Just add, and then we can jump to main. So this is gonna run forever, but let's actually try it. Let me make sure I didn't. And it goes forever. So did I use an incorrect operator or something? I did actually. So that is the issue that we were having earlier, but this is jump 0, not JZ. Okay, so right, there is another issue. Dupe, that should be fine. Next swap, push, add, continue. Let's add 5. Maybe it's 0 jump actually. Now that I'm thinking about it, I could check pretty easily, I suppose. But yeah, all right. So that seems to be the issue. So 3 or 5.10, and we'll do the first 10. Index out of range. Okay, so what index is out of range? Let's see. I think we need to actually do jump in. Because let me start there. Stack over. so that is progress. Let's actually print the stack on each iteration. Should probably add like a flag to do this, but I will not do that right now. So print stack machine, and we should be able to see what is going on now. We rebuild this. I can type. Alright, and we run that. So 10. So where is that? Yeah. We never actually decrement that number. I mean, yeah. Because that's supposed to be the count. Yeah, that's probably kind of important to do actually. Uh-huh. Let me not do that actually. And alright, it goes forever. So why does it go forever? Uh-huh. So yeah, we do need to decrement that. So that is a problem actually. So what we can do is in swap 0. Or yeah, and then push 1, add, and then just in swap 0 again. And let's see, that might actually fix the problem. Maybe not, but it could. So it does not. Still goes forever. We want to sub, actually. And then we actually want to compare. Let's actually make a loop here, because we don't want to push that every time. So we're going to jump to loop. Yeah. So in the loop, we actually want to we could check it down here actually. So that actually places it back. So instead of placing it back, or before, so we sub and then we push 0 and then compare equal. And then so jump if it's 0, not 0 jump, we'll jump to end. Otherwise, we'll just continue here, we'll swap that back, and then we'll jump to loop. And we'll put end here, and that will push 99 and print, so we know it's the end. Alright, so yeah. Whoops. Alright, and it overflows. Okay. So let's not print the stack. And let's see what it actually prints. Right here. Alright, so if we build it again, and then we run chasm. Alright, stack overflow. So yes, so let's actually print. Alright, what do we want to print? Let's see, we can print any number. Actually do, and then print, and then that should not interfere with it. Alright, so 0. Alright, so we go through many iterations, and it is always 0, it seems. So there seems to be something wrong with our logic here. So let's see. Push 3. Yeah, we want to push 3 every time. And then mod. So why does 0? Why does it print 0 every time? That is interesting. Let's see. Let me run through it again. So we have 10, 0, 1, and then we start the loop, so that's 3. And then actually we dupe it, so it's 1 and then 3. We compare them, so it'll push 0. And then yeah, so if it's 0, then we jump to add 3. So that will do index swap 1. That's this one. So it just swaps those. And all right. And then push 1, add. So it becomes 1. And then you swap it back. So it's like that. Okay. And then we go to continue. So that's right here. Then we duplicate it. So it becomes 0. And then we push 5 and we mod. And it's 0 again. So 0 jump to add 5. And we index swap with 1 again. So that's 0 and then 1. Yeah, so this seems to all be working. And then 1. Becomes 2. And then we swap it back. So this becomes 0 and this becomes 2. So we have 0 on the top. And then we jump to cunts. And then that will push 1. And then add it. So it should be that. And then index swap with 0. Alright, so why are we adding here actually? Because we want to... Yeah, so this should be added, I suppose. I'm not sure exactly. I don't remember. Alright, so this actually becomes 10, and this becomes 1. So we have 10 on the top. And then it should duplicate that, and it should be printing 10. So why is it printing 0? So what if I get rid of this 1? So 2 and then 11 and then 1 and then 99. So that's not right. Okay. So actually, I don't know why it would be doing that. Like, so that should be swapping it, and then that moves this one. It should move this one to the top. So I don't know why it wouldn't. Why would it not? Maybe this will be, let's see if there is another one, perhaps. And we can come back to this one. Take a break with something else. Let's see. Probably, I'm not sure. Palindrome. Seems kind of complicated to do with what we have. Anyway, 13. So we've done Fibonacci, not just specifically the even ones, but okay. Some of these work better with stack-based machines than others. Names.txt. Alright, I'm not gonna read from a file. Because we can't do that actually. I want to be able to implement syscalls, but like cross-platform. So I think I'm not sure if the C like has right. I'm assuming that is cross-platform, but I'm not sure. But if we could implement that, and basically have support for any syscall, or at least the major ones, then it becomes a whole lot more powerful. We'd probably want string support for that before that though. So yeah. Once you have strings and then syscalls, crazy stuff. Perhaps a prime thing, or just prime factor. So so is that math? Okay. So is it then 5 times 7 times 13 times 29 is that? Yes. Okay. I'm not sure. Let's see. How to find prime factors. Not sure exactly how you go about doing that. But if we find a formula, we could probably implement that. I might just come back to this. Repeated division. Okay. Let's see, is there a better one? I don't really like that website. Let's see. This is for like children in elementary school. Okay, 12 is that. Largest prime factor. Da 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 da. On the largest prime factor of a number. Okay, so we have a list of them. We don't have support for lists in our language, our assembly language, so that's a thing. D equals 2. While n is greater than 1. Alright, so we could technically do this besides the list part. Because we do have jumps and comparisons, and that's all you really need for while loops. Yeah. So, Right, that's kind of cheating, but Alright, so this is more efficient. Let's see. Perhaps we'll do a simpler one. How about just finding the prime number? Let's see. So, prime number, yes. We need to go through every number, basically. Let's see. Calculate primes. I forget how to do it, because I am stupid. Okay. Formula. Okay. Prime number can be divided without a remainder, only by itself and by 1. Yes, so know that. So like you could check if one number is by So actually what they call it again? Objects. Give me a moment. Let's see. Yeah. Alright. Whoops. Alright, yes, right here. I solved it in C, but you could probably reference it. Prime. Where is, I thought I had a, oh yeah, next prime number. So we could get an idea of how I did it in the past. Yeah, so this is looking at half of it, and then so that's using return. So we don't really have return in our language. But I think we could check. Yeah, okay, I think we could do it. I think we can do it. Let's do prime numbers, and then I'll open that up. So let's see. So so is prime. We don't have underscore. So let's see. So we'll push the loop number. So actually it needs to be half of the number. Push 2 and then div. So I'm assuming we'll have the number at the top of the stack. That's what we're assuming right now, at least. Let's see. Then divide. Let's see. So if it is, all right. I forget. Man. Okay. So for loops. So if that is greater than or equal to I, so we need an I. Which one is I? We can't actually put it there right now. But so that's I, the index that we are at. So we need to make sure. So yeah, then we can actually swap it. Push 2, and then we'll do. And then, yeah, so that would remove the number that we had. So then we would just have 1 and then the value of the whatever divided by 2. So then we need to compare less than or equal I. So yeah, I think that's what we need to do. Or maybe it's, I'm not sure. So if it's 0, I don't know. I don't know where to jump yet. But then otherwise, 0, then we'll jump to prime n. I think that's where we need to go. So prime n. Yeah, so we have a label there. And then we need to do this if statement. So we have the number, but we actually get rid of the number. So we need to duplicate it. Yeah, and then we do. But then we need to swap again. So, we can't just swap because, so we'll have, let's say it's 4, right? So we have 4 here, and then we have 2 4s. Then we have a 2, and then we divide them. Yeah. But then we want to actually compare with this one. And I don't know what index that we add as. Push 2, div 1. So we'll push 1 for now, and we can modify that. And then, yeah, we'll compare, jump to the end. All right, so now the if statement. So now we still have that number. It is actually there. So push 1. So that should, yeah, so it should be right on the top actually. So then we need to do, but we need I again. So we need to dupe I. But then that breaks it again. So dang, this is confusing. I'm not used to working with stack-based languages, so I am very sorry. Perhaps we should start with the main. Then we can get an idea of where it would be on the stack. So the input, we don't care about that because so we're just checking a number, a single number, to check if it's prime. That's what we're trying to do right now. So num equals 2. Okay, that's kind of weird. Why are we, okay. Num equals 2. So yeah, we can just push 2 for that. And also we need to push the whatever we're comparing. So 50, for example, which is not prime. So then, right, so then wall 50 is not equal to 0, so we can swap. And then, yeah, actually we don't, yeah, we need to swap. And then we need to compare, or yeah, push 0, compare equal, and then jump, 0 jump to n. N. 29, okay. So now we have that. So that should be the loop. So we need actually a start of the loop. So loop right there. Okay, so we just need to make sure whenever we restart to the loop, we'll do that. Let's see. So we've got this now. Now we need the for loop. Yeah, and that's just calling that. This is a very weird program. We're calling it 3 different times. Okay. Let's just copy this table and paste it in the program. Yeah. I don't think I'm gonna be able to finish this today. Because I do have to go now. Yeah. So I'll just add a to do at the top, and then yeah, to do. Yeah. So I'll build that. So I'll get add dot. Added to do tags on assembly challenges. Okay. So that is should be live on the GitHub now. So yes, I'm going to stream tomorrow earlier so right now it is about 9 p.m. my time, Eastern Standard Time. That's what. So I'm gonna be streaming at 8:30, about 8:30 a.m. tomorrow. Just so, and that'll be my last stream for about a week. Because I'm going out of town. So yes. So I won't be streaming for a week, basically, is what I'm saying. Yes. All right. So that is it. Thank you for watching. I appreciate it, and I will see you next time. Goodbye.